This lesson we're going to cover graphs and reflections of the graphs and what those reflections actually entail, what they mean. So let's just go through the examples first. It's relatively straightforward. They're asking about reflections across various axes. The first one is a reflection across the x-axis. So if I'm going to take this x-axis, I'm going to reflect all of these points. That means that all these points are going to go down to their corresponding negative y version. So if this guy has a positive y value of 4, this will be a negative y value of 4. This guy has a y of 4, so his counterpart, his reflection, will have a y of negative 4. This guy right here, I'm going to say that the top of the semicircle is a 1, so I'll put him at negative 1. And if I drew out that semicircle, like so, that's where he would rest. So that's a reflection across the x-axis. We take the negative y versions of itself. For the next example, we're going to make a reflection across the y-axis. So all of these points are going to become the negative x's of themselves. So if this is a positive 2, it's going to become a negative 2. If this is a positive 7.5, this becomes a negative 7.5. This looks like the top of the semicircle, the bottom of the semicircle is at approximately 5. So I'll put this at approximately negative, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, yeah, about negative 5. Looks good. So that's a reflection across the y-axis. Now the most complicated one is this guy right here, example 3. Graphically reflecting a function across the line y equals x. Now if you remember from Algebra 2, this has a very important meaning. This is actually the inverse function. But if you don't remember that, we're going to cover it soon. So all you got to know is that this guy is, let's draw that line, the y equals x. If this guy is a certain amount of distance, let's pick a different color actually, so you can kind of see those changes. You see how this guy from this axis, this line, is approximately that far? So we're going to go the opposite direction and put that point right there. The same thing for here. This guy is down and right a little bit, where we're going to go up and right a little bit. So the point becomes something like, if this is 2, 4, this guy becomes there. And we'll go over what the mathematical interpretation of this is. We're just switching our x and y values. So if this is a 2, 4, we're going to make it a 4, 2. This is a 7.5, 4, so we're going to do 4, 7.5, which is about there. And it's got to cross over here and go something like that. So that's the most complicated one, is making this reflection across the y equals x line. Example 4, when we reflect across the origin, that means you go one reflection across the y-axis and one reflection across the x-axis. So both the x and y's become negative versions of themselves. So that becomes that. This guy right here, since he's 7.5, 4, this is going to become negative 7.5, negative 4. We'll put this about there. And that's what happens to that semicircle. He's reflected across the, see how if I have these points right here, I'll show you. If you've got these points like that far away, it's a reflection across that origin. Okay, so what do these mathematically mean? Well, for our first one, when we reflect it across the x-axis, it just means we take the negative y's of the graph. The x's stay exactly the same. So this is still negative 5, this is still negative 2, this is still negative 1, this is 4. But the y's become the negative versions of themselves. So 4 becomes negative 4, 2 becomes negative 2, negative 1, negative of negative 1 would be positive 1, and then negative 1. And if we plug that into the graph, let me pick a darker color, this would become there, this would go down 2 to there, this guy goes there. this guy's up 4, so let's make him go down 4. And then we connect those lines. And you get that graph. So perfect reflection across the x-axis. Now the y-axis, if I'm going to reflect across the y-axis, it's going to be slightly different. It's going to be that the x's become the negative versions of themselves. So negative -5 becomes positive 5. Negative -2 is 2. Negative of -1 is 1. And this is -4. But the y's stay the same. So this is still 4, 2, -1, and 1. And if I plot that out, this becomes 5, 4 up there. And pick a different color, a darker color. Hopefully this guy doesn't burn your guys' eyeballs. That one there, this guy right there, and that right there. And that right there. So that's a reflection across the y-axis. Now, I had mentioned before that the reflection across that line y equals x, that's this line right here, y equals x, that is going to be the most difficult one for conceptualizing, but mathematically it's relatively simple. We just swap these values, the x and the y is swapped. So if this is -5, 4, we're going to make this 4, -5. If this is 2, -2, this becomes, sorry, -2, 2, this becomes 2, -2. This doesn't change at all. And this becomes 1, 4. So if we plot out those points, 4, -5, which would be down there. Let's again pick a different color for this guy. So that guy's there. Let's see. We got 2, -2, so he'll be down there. -1, -1, so he's on that line. So if you have any point that crosses this line, the reflection should also cross the line at that exact same point. And the last one would be 1, 4. Wait, should be right there. And that's again a reflection of this point. So if I connect all of those guys, this connects to there, that connects to this, and that connects to that. So that's our reflection across the line y equals x. Final one that we did is a reflection across the origin, and that's when you just take the negative version of both the x and the y. So this becomes 5, -4, this becomes 2, -2. Now we didn't swap them, we just made both of them negative. This becomes 1, 1, and this becomes -4, -1. So if we plot out those points, we'll get 5, -4. Let's do darker right there. 5, -4, 2, -2, 1, 1, and -4, -1. And that's our reflection across the origin. So that covers all of the graphical reflections. We're going to talk about what those mean in the following unit.